In this video, we're going to take a look at some properties of parallelograms, similar to what we did in the previous video when we looked at kites and trapezoids. So we are not going to complete the warm-up right now. So to begin working on this, remember a parallelogram is a quadrilateral whose opposite sides are parallel. Some special types of shapes that fall into this category are rhombuses, rectangles, and squares. So anything that we figure out in this video also applies to those three shapes as well. So the first thing that we're going to do is we're going to jump over to Desmos and we're going to look at two different properties of parallelograms. So the first thing I want you to do is I want you to pay attention to the opposite angles in this parallelogram. And by opposite angles, I mean angle B and D are opposite and angle A and C are opposite. They are across from each other. So as I adjust this, I want you to just jot down what you see as a similarity or what you notice about the opposite angles. And what you should notice is that angle A and C are congruent and angle B and D are congruent. So what we could say about the size of the opposite angles is that they are congruent. Now, if we come back over here and we take a look at this next slide, I want to talk about what we notice about consecutive angles. So if we look at this, angle B and angle C, the measure of angle B and angle C is 121 and 59 respectively. Okay. Now let's adjust this and make a different parallelogram. We have 125 and 55, so we're going to record 125 and 55. And let's create two more. So 130 and 150. So we have 130 and then we have 50. And finally one more. 138 and 42. 138 and 42. And what do you notice about the sum of those two angles? You should notice that they all add up to 180. So if we jump back over here, we can say that the sum of the consecutive angles is 180 degrees. What's that lead us to be able to say? That means that those two angles, the consecutive angles, are actually supplementary. So we looked at a number of trapezoids in both those instances, and that can lead us to be able to make two conjectures. The first one being the opposite angles of a parallelogram are congruent. So we now know that if you have a parallelogram, the two angles that are across from each other are congruent. Whereas the consecutive angles, they are supplementary. They add up, the sum of those two angles is 180 degrees. So what we are going to look at then is another conjecture, but before we jump to that, I want to just take a second to think about this question. It says, describe how to use the two conjectures you just made to find all the angles of a parallelogram with only one angle measure given. So let's say we had a parallelogram. Make sure we marked everything as being parallel. And let's say we knew that this was 45 degrees. Okay. So if we only have one angle, then we can use, how could we use these two conjectures to figure out the measures of the other three angles? First of all, we could use the opposite angles conjecture to figure out that this is 45 degrees. We also know that these two angles have to be congruent as well. So we have this is congruent to this because they are opposite angles. Now, we also know that consecutive angles have to add up to 180 degrees since they're supplementary. So 180 minus 45 would give us 135. Okay, so that tells us that this angle would have to be 135, as would that angle, because they are opposite, which means that they are congruent. So that is how you could use those two conjectures to figure out the measures of three missing angles in a parallelogram. Now, let's take a look at our next conjecture. And I want you to take a look at what you notice about the opposite sides. So the opposite sides here would be AD and BC, which are both green, and AB and DC, which are both purple. So what do you notice about the opposite sides? You should notice that the opposite sides are congruent. So we can jump over here. We noticed that the opposite sides of the parallelogram were congruent, which, again, I'm doing this, creating tons of different parallelograms here right now. They are always congruent. The opposite sides are. So we can jump to making a conjecture based off those observations that the opposite sides of a parallelogram are going to be congruent. Now, the last conjecture that we're going to take a look at is we're going to take a look at what happens with the diagonals of parallelograms. So what I want you to see is, hold on. So in this right here, it says AC and BD are diagonals of a parallelogram ABCD. Try to move the purple points of parallelogram ABCD so that the midpoints of AC and BD are different. Can you? What conclusion can you draw? So if you're looking at this right now, the black point in the middle represents the midpoint of DB and the midpoint of AC. Right now, you can see that the red line, the red diagonal, and the black diagonal, they intersect at the midpoint. If they intersect at the midpoint, that means that point bisects each of those diagonals. So I'm going to change this parallelogram. And what I want you to do is I want you to see, do the two diagonals always intersect at the midpoints of each other? There, they intersect at the midpoints. So if that black dot in the middle is the midpoint, that means AC is bisected, and that means BD is bisected. Let's look at this one. Make a different one. Again, you'll notice that the black point in the middle, that is the midpoint of DB, and that is the midpoint of AC. And both those diagonals are now bisected. Okay? So what you'll notice is if we keep doing this, doesn't matter what parallelogram we create, any parallelogram that we create, the two diagonals intersect at their midpoints. What's that mean? That means that the two diagonals bisect each other. And since we saw that happen for pretty much every parallelogram that we created in that quick example, that means that we can lead ourselves to this conjecture that says the diagonals of a parallelogram bisect each other. Okay. Now, these investigations, they may have convinced you that the parallelogram properties are true, but what properties explain why they are true? Okay, that's what we want to think about in these next two proofs that we're going to do. And again, jumping back up to here, what we now know is that if you have the diagonals of a parallelogram, they are going to bisect each other, which means that this EM is congruent to MO, LM is congruent to MV. So what we're going to do is we want to, prove that some of these conjectures are true. But in order to prove that these conjectures are true, we do need to prove a lemma. So you recall that a lemma is another smaller theorem that you can use to prove some of the conjectures. Okay, we've had to do that before, where we prove one thing in order to prove our conjectures. So in this instance, what we need to do is we want to prove that the diagonal of a parallelogram divides the parallelogram into two congruent triangles. So if you look at this, that means that this triangle would be congruent to this triangle. Okay? So we have a flowchart proof here that we're going to sort of fill in the blanks of. We know that SOAK is a parallelogram. We know that because it's given to us. We also know that OA, so here's what we know. We know SO is parallel to KA. That's the definition of a parallelogram. We also know OA is parallel to SK. How do we know that? Because again, that is also the definition of a parallelogram. And I'm going to cheat and just write that down right there. So that's the definition of a parallelogram. Now, we know that because SO, we know that since SO is parallel to KA, that means that we know angle 3 is parallel or is congruent to angle 4 because that is an alternate interior angle. Now, we also know that angle 1 is congruent to angle 2. And if you think about why that is, it's because if you know that SK is parallel to OA, then that means that 2 and 1 are also alternate interior angles. So I'm going to copy that, write it down right there. Okay, so those are also alternate interior angles. Now, we also know that SA is congruent to SA. Okay, we know that SA is congruent to SAs because they are the same segment. Okay, so SA, what we're looking at is right here, SA. So SA is shared by both triangles. That means that this is the same segment. So what does that mean? That means that triangle SOA is going to be congruent to triangle AKS. And how do we know that? Well, we have angle, and we have a side that's congruent. So 1, and then we have 4 and 3 that are congruent. So we have angle, side, angle. So we have reason for those two triangles being congruent is angle, side, angle. So we've shown that in fact, if you take a parallelogram and you draw in a diagonal, that you do in fact create two congruent triangles. So what we're going to do is we're going to use that lemma to prove the parallelogram opposite angle conjecture. And then the other ones will be done later. So again, we want to prove the opposite angles of a parallelogram are congruent. So again, we have a flowchart proof. We are given that parallelogram BATH with diagonals BT and HA. So we have this shape over here. We want to prove that HBA, so this angle right here, is congruent to ATH, so this angle right here. And we want to prove that angle BAT is congruent to THB. So if we take a look at this, we have parallelogram BATH with diagonal BT. We're given that. Parallelogram BATH with diagonal HA. We're also given that. Then we have triangle BAT is congruent to triangle THB because we know the diagonal creates two congruent triangles when you draw a diagonal in a parallelogram. So that's what we just proved. So we have that. Then if you look at triangle BAH, we drew in the diagonal HA, so it created triangle BAH, and it also created triangle THA. Okay, so we know that triangle THA is equal to or is congruent to triangle BAH. Again, why do we know that? That is the lemma that we just proved. We just proved that if you draw a diagonal into a parallelogram, it is going to create two congruent triangles. So we get angle, this top part leads to angle BAT. It is congruent to THB because of CP/CTC. And then we now know that angle HBA is congruent to angle ATH because of, again, CP/CTC. So that is basically how you would go through proving each one of these conjectures. So what we're going to do is we're going to wrap up this video by looking at two extra examples. So in this first example, it says if the perimeter of the quadrilateral equals 52 centimeters, what is the value of x? And so what we know is that we're talking about the perimeter here, so we're talking about the lengths of the sides. We know that the opposite sides in a parallelogram are congruent. So we know that this is x plus 2, and we know that this is 2x minus 3. So what we have is we know the perimeter is equal to 52. So if we add up all of these four sides, so we have 2x minus 3 plus 2x minus 3 plus x plus 2 plus x plus 2, that's equal to 52 centimeters. So 2x plus 2x plus x plus x, that's 6x. Minus 3, that's minus 6. Plus 2 is minus 4, plus 2 is minus 2. That's equal to 52. We add 2 to both sides. You get 6x equals 54. Divide by 6, x equals 9. And you can always double check your solution or work by plugging in. 9 plus 2 is 11, 9 plus 2 is 11. 2 times 9 minus 3, 2 times 9 minus 3. You get the same thing on all four sides. Okay, so when you're dealing with perimeter, you're typically going to use the fact that you know that the opposite sides are congruent. Now, given parallelogram ABCD, solve for x. So that's angles, that's vertex C right there. So if we take a look at this, here's what we know. We know that, and there's multiple ways of being able to solve this. Let's use the conjectures that we used in here. So what we know is that when you have parallelograms, the corresponding sides are going to be congruent, or not corresponding sides, consecutive sides, or consecutive angles are going to be congruent. You also know opposite angles are congruent. So I said that wrong, my fault. Opposite angles are congruent, consecutive angles are supplementary. So if we come down here, we get this. We see that 2x should equal x plus 10. Those are opposite angles. 2x should equal x plus 10. So if we subtract x, you get x equals 10. So we solved for x. That's one way that you could do it. Another way you could do it is you could say that x plus 10 plus 110, oops, my fault. Yeah, x plus 10 plus 110 equals 180. So if we do that, scratch that. Let's just use this. So again, what we used here was, we know that those two angles are going to be congruent. So you get hold on, that's not working out right. Let's backtrack on that. So let's go ahead and use our example for where we know that, core or consecutive sides are supplementary. So we have 2x plus 110 equals 180. So if we subtract 110 from both sides, that'll give us 2x equals 70. And then if we divide by 2, we get x equals 35 degrees. Okay, so we get x equals 35. Now, let's also double check. So we have 2x. We know that 2x should equal x plus 10. And again, we just did this one. You subtract x, you get x equals 10. And so what happens here and when you take a look at this, is that you notice that you have x equals 35 and x equals 10. Obviously, x cannot be equal to two different things. So in this case, you have no solution. Okay, so if you take a look at that and you find yourself getting two different answers, that means that you have no solution. Another way that you could have done this is if you did that first, if you plug in 35, you would get 70 right here, and then you would get 45 right here. Again, you know that's not correct because you know that these two angles, A and C, have to be congruent. They are not. So again, this parallelogram has no solution. So go ahead and start working on your homework. If you have any questions, message me on Remind or email me. Please check your solutions on Canvas and ask any questions at the beginning of class.